A3-T61-01G. In this particular question, our ask is, what is the flow rate in US gallons per minute? That's important to distinguish it from imperial gallons per minute. So we want to know our flow rate through the coil using the temperature method. So this is another standard formula from your reference manual. And based on information we already have, it's very easy to calculate what the rate of chilled water is flowing through the coil, because we know the flow rate through the coil. We know the sensible heat capacity of the coil. And what else do we know? We also know the change in dry bulb temperature. So we can plug that into our equation that looks like this. So from your reference manual, Q, which we've already calculated, by the way, in BTUH, sensible heat formula, for a flow rate, Q is going to be equal to the GPM of the coil. That's actually what we're trying to find, times the constant 500 times delta T, right? And in this case, you're talking about the change in the chilled water temperature, not the air temperature, because we're talking about the coil. We're not talking about the airflow. So we can rearrange this very quickly to solve for GPM by dividing both sides by 500 times delta T. So I divide that side by 500 times delta T and this side by 500 times delta T. And you can see that these obviously cancel over here. So now we end up with a very simple formula. I'm just going to flip it from right to left to left to right. So we end up with GPM, right? This is US gallons per minute, by the way. This formula is for US gallons per minute, is going to be equal to Q divided by the constant 500 times your change in chilled water temperature. So let's put in our numbers. We already know the capacity of the coil because we know how much it cooled the air when we previously calculated the amount of cooling it does. So it's going to be absorbing 359,596 BTUH, right? BTUH, we know that. And we divide that by 500 times, what was the change in temperature? It was a 10-degree change in temperature on our chilled water coil. That was given in the question, right? The supply chilled water temperature subtract the leaving chilled water temperature. And I believe that it entered the coil at 45 Fahrenheit and left the coil at 55 Fahrenheit. It warmed up, obviously, because it picked up heat energy from the air that it's cooling. And so we got a delta T of 10, and we just simply plug all that in, and we end up calculating 80.9 US gallons per minute. US gallons per minute. So we go back to our question, and we can very, very simply see that the answer is going to be D, 80.9 gallons per minute.